Hello and most welcome to Heidegger 1395. We are presently in the so-called palm house with tropical plants and a water basin smack in the middle. It's heavily lit, so for those ones who are missing the sunshine, this is a perfect spot to get some full frame daylight. I will continue with the comments from Emrén and use Chiara Marletto's The Science of Can and Can't, and use counterfactuals to get some understanding to it. As we've seen, counterfactual can be very helpful. We got some excellent comments from Kalle Lundahl, my cooperator, the other day. And is it possible to have different views but still be in concordance? It's just sheer excellence. Of course, knowledge itself is also under the same rules of counterfactuality. Knowledge is not monosemic in itself, and it doesn't follow out of universe preemptive laws that decides what is real and what is unreal, what makes sense and what does not make sense. Another way of expressing that is to say that knowledge can not be an exception from the quantum physical function of complementarity and mutual exclusiveness. No knowledge itself is part of complementarity. The double take of particle and wave, if you prefer. This is decisive and utterly important in order to understand there is a great risk if you stick to the old representative understanding of knowledge and try to enforce that on quantum physics. Knowledge doesn't in itself have a green card that says, well, classical physics can somehow continue outside of physics. No knowledge itself is deeply counterfactual. It is not monosemic. It has the same features as everything else: contradictory, non-identical, and non-linear. That does go for knowledge itself, not being a close exception, still valuing the same solutions, being part of reality, and therefore information, as Chiara explained, is in itself counterfactual in its becoming and in its existence. We try to make knowledge linear. We allow knowledge to be limited by paradoxical, homogeneous thinking, like the panopticon, or the idea that you can observe the universe from the outside. That is not knowing the character of knowledge itself. If it's not fertilized properly, knowledge will not grow like these magnificent plants that surrounds me. Contrafactuals is a way of reinvigorating knowledge, making it wholesome again. By introducing a whole from where it can breathe and continue to exist. The whole is what Stephen M. Rosen calls the interpenetration. Knowledge is in itself in desperate need of an interpenetrating whole. What does that mean? It means that also knowledge is dependent on a subject and an object, and that mutually exclusiveness of object and subject is the invigorating, life-bringing, self-penetration of the Klein bottle. an absolute necessity for a widening and deepening of the fractality of knowledge. According to the great scientist, logician, philosopher Douglas Hofstadter, we make irredeemable damage to knowledge by, like what Kurt Gödel did, trying to make it coherent and consistent. We think that we are ordering knowledge, putting it into truth tables, making the verticality of the alphabet with vowels and lines that cut understanding apart, already in its very inscription. Allowing contradiction, counterfactuality, opposing paths to inhabit knowledge, it becomes healthy. Healthy means more whole. The constant carving and halving within neo-academia wanting to make knowledge true, veridical, representative. This is taking one part of the false, the shadow, l'absence, as Jacques Derrida called it. And for every new cut, knowledge becomes scarcer, cramped, festering, as we ourselves in our mentality and body become fixed, tensed, non-flexible, not allowing opposing views or seeing them as something that needs to be compromised, weakened, or in antipodal position leads to war. Like the ravaging war now going on between brothers in Ukraine and Russia. Festering within oneself is the idea that the positive lit side of one's thoughts are the only part to be focused on. That makes for a stressful, crowded, and frictioned thinking. In the examples of Emrén, Schrödinger's cat, which would be the next subject, takes a decisive role of showing understanding, reality, and theory to be much deeper connected than previously thought of. Regarding the Schrödinger cat example, page 10, paragraph 2, the thing that kills the cat is not the radioactive substance, but your observation of the animal. Through your observation, the undecidedness disappears. Now the cat is dead or alive. Comment from Emrén. This is wrong. What killed the cat, if you find it dead, is not your observation. It was killed by the poison. And this happened independently of you opening the box or not. You forced the universe to choose one of the numerous realities that already exist. You only observe what has already happened. It is impossible to make a cut between imaginary and real. It doesn't even make sense to cut out imaginary phantasms, fantasia from reality. Our problems to understand what happens are deeply ingrained in our inability to understand counterfactuals. In my reading, it sounds, at the first take, oddly similar. It is indeed very hard to tell the difference between the way to put it, as Emrén did, the comment, and the original text. But think if your opening of the box is in a future that is affecting the past, then you might understand what happens. Retrocausality takes a big place here. Remember 1393 and 92, where when we read Emrén's text and he showed non-real imaginary photons taking an active part in what happens. They are of the future. As I said initially, our understanding needs to be contradictory as well. Otherwise, we will have one leg still in the classical paradigm. The next comment, 10, paragraph 3. Paradoxically, in that same paper, Schrödinger argues against his own thought experiment. That prevents us from so naively accepting as valid a blurred model for representing reality. Comment from Emrén. No, Schrödinger does not argue against himself. He argues against the natural thought that cat, being dead and alive, means that it is in some kind of intermediate state. Something like half dead. Page 10 to 4. Thus, Schrödinger criticizes his own proposal, explaining that the cat is in a state of indeterminacy. Does not reflect reality. It is like a blurry photo. Unscharf eingestellten Fotografie. Comment. It appears that you have slightly misunderstood the Copenhagen interpretation, the one that Bohr, Schrödinger, Heisenberg, and Dirac had arrived to. In 1935, they had struggled for 10 years to get some kind of sense out of their discoveries. Remember, this was much harder for them than it is for any of us who are more or less grown up with duality. What he tries to tell in this sentence is that any kind of parable we take to explain does not contain the truth. Darüber man nicht reden kann, sollte man schweigen, as Ludwig Wittgenstein said. Over what you cannot talk, you should remain quiet. I take that to be the essence of Emrén's comment and the point of Schrödinger's parable. Wittgenstein meant that the very most important are things we cannot talk about. The truly foundational things in reality, like consciousness and matter, are not to be spoken about. The later Wittgenstein changed his view on the contradictory nature of representation, knowing it were the inexplicable language games that became a way of pointing or snapping his fingers in front of the viewer's lulled and sleeping knowledge. To wake him or her up to her or his reality. Their lives, to be alive. It reminds me about what Ian McGilchrist says about people who suffered a brain hemorrhage in the right hemisphere. They do no longer understand time. They see only pico moments sweeping by, small nows in an endless speed. Their world is essentially deriven of any life, any movement. It's absolutely still. Now we continue the recording in this sanctuary, this absolute haven. So we have a tropical day here on the inside, whereas the outside it's around 0 and foggy. Could even be starting to rain pretty soon. Looks that way. Emrén so aptly put it, they were the pioneers. They had nothing to compare with. They had to do all the way down to the basic for the very first time. That is just an incredible feat. Beyond belief, I would say. To set things clearer, and I think counterfactuals are needed for the understanding. Because without the understanding process itself changing, developing, becoming different, as was the fact with the pioneers within quantum mechanics, we need to have an expanded counterfactual understanding, not a consistent, coherent, representationalist thinking procedure. It takes long time to change that. And it's very different from the regular neo-academic understanding as grasping. You nod your head and say, I have understood. I have put it into my consistent and coherent system. It makes sense. That is as far from the truth as you can get. It will not lead you to the desired understanding of quantum mechanics. I will continue where I left off in the book by Chiara Marletto in 1394. And we were talking about information being dependent on counterfactuality. And when there is no counterfactuality, there is no information. Like in the example of the bridge, where the light only has one state. So to speak, already collapsed. We have reached an important conclusion. A physical system is capable of carrying information if it has these two counterfactual properties. One, it can be set to any of at least two states. The flip operation is possible under the laws of physics. Two, each of those states can be copied. The copy operation is possible under the laws of physics. So here is the reason why information is a physical property. Whether or not some system carries information depends on whether the laws of physics allow for these two transformations on that system. If they do not, then the system cannot carry information. If they don't, then the system cannot carry information. In a universe where no system had both properties, information would not exist. So whether or not information is permitted depends on whether the laws of physics permit certain kinds of counterfactuals. but it is not a property like having a certain color or mass. That is, factual properties of a system. It is a counterfactual property because whether a system contains information or not depends on whether those two transformations can be realized on it. Through counterfactuals, you have arrived at the elusive connection between information and physics. Systems with those two properties are information media. All information media, despite their differences, have in common the fact that those two transformations are possible on them. All the systems I mentioned in the Sentosa example are information media. They have those two counterfactual properties. The simplest information medium the fundamental unit of information is a bit. It is an information medium with two possible states, 0 and 1. Its capacity is that it can signal at most two different messages. You can think of countless ways in which our universe can embody a bit the lamp of our previous example, which can be on or off, an arrow that can point up or down, a coin resting on a table which can show heads or tails. Your answer to a yes or no question, and so on. Thinking in terms of information allows one to forget about all the differences in the physical details of those systems. And consider them as all as the same thing, a bit. The same holds for information media with higher capacity, those that can hold more than 2 messages. They too can be thought of as made of bits. But not every system is an information medium. A good example is a memory in a computer that is full but cannot be erased. It is possible to read information out, but not write new information in because no more space is available, and reset is not possible. It was an information medium once, but no longer. You could also have a case where information can be copied in, but not out. Have you ever tried to write something on the foam on top of a cappuccino or a beer? At first it looks possible, but the letters rapidly fade away to the point that they can no longer be read. Neither of these two types of systems would be capable of carrying information because they do not have enough counterfactual properties. They are not information media. One of the most striking properties of information media is that in that regard they are all interchangeable. Because information can be copied from one to the other, irrespective of their physical details. I shall call this property the possibility to copy information from any information medium to any other, interoperability. For example, the information in a bit can be copied into any other bit, irrespective of what physical system it is. A transistor, an arrow, a coin, or a switch. The music that has been recorded on an old vinyl disc, on all vinyl discs, can be converted and copied into digitally encoded music on a flash memory. The sound produced by our voice can be turned into words stored in the transistors that compose the memory of our smartphone. Via voice recording, the thoughts in my head can now be faithfully copied on this page. They will then be copied into your brain and then possibly copied further into other brains or your notebook. If you decide to write them down. All these information media are interchangeable or interoperable, and information can travel among any of them without restriction. Interoperability is due to the fact that all information media have in common properties. The two counterfactuals I mentioned above. That transcend most of their specific details. That is, whether they are photons, transistors, the spins of an electron, neurons, or switches in a lamp. In all these cases, when interested in the information processing abilities of these systems, we can abstract away their irrelevant details and simply talk about them as information media. Considering their information-carrying attributes only. Now armed with these counterfactuals, you can understand why information looks like an abstraction. And yet is grounded in counterfactual physical properties. Just going to have a check on the time here. When talking of a bit, we do not need to mention what physical system embodies it. My comment here is, now you can see how knowing and the physical system is disparate, but at the same time, they are identical, so to speak. There is no difference whatsoever. An arrow up is entirely physical. but it is also entirely information. 100%. It never loses its materiality, although sometimes we ignore it. Its abstractedness is not an emergent factor. It has always been there. What matters is that a bit is an information medium, entirely defined by its counterfactual properties, which hold irrespective of its physical details. What is the connection with physics then? The key is that which physical systems are information media and which are not is established precisely by the physical laws that rule our universe. The key is that which physical systems are information media and which are not is established precisely by the physical laws that rule our universe. And the interoperability of information media is a counterfactual property of physical systems. It is a property of the physical world. Just like the color of the summer sky, the shape of the rainbows, or the attractive interaction that holds between charges of opposite signs. Time and again, you will see that seemingly innocuous and simple properties, such as interoperability, have far-reaching consequences. In this chapter, I want to explore one of these far-reaching consequences of interoperability. The possibility of copying information from any physical support to any other is necessary for computers to exist and all the related information technologies. Because computers rely on the counterfactual properties of information media in a fascinating and subtle way. I want to open a digression about computers. In certain circles, computers have an unfairly poor reputation. In traditional physics, for instance, they are regarded as emergent macroscopic systems, thus not at all fundamental or worthy of attention, unlike, say, elementary particles. In the general culture, they are regarded as having interest only within the niche made up of geeks, like the character Sheldon in The Big Bang Theory. At best, they are perceived as useful but dull machines that are only slightly more interesting to us than a dishwasher or a vacuum cleaner. In fact, we would not consider them at all were it not for the fact that they happen to be useful for typing up essays, playing games, writing emails, shopping, dating, and socializing. All these views are inadequate because they disregard the fundamental aspect of a computer. The intimate connection between computers and the laws of physics, which goes via counterfactuals. Let me start with the link between computers and physics. Computers are embodied in physical supports. They are made of information media, typically billions of switches or transistors. Therefore, they are ruled by the laws of physics. Computers are embodied in physical supports. Very important. In particular, which computations a computer can or cannot perform depends on what the laws of physics permit. This connection between computation and physics was not fully understood until the 1980s with some of the pioneers of quantum computers. It was hinted at by imaginative thinkers such as Rolf Landauer, Paul Benioff, and Richard Feynman. But it was fully expressed for the first time by David Deutsch and further developed by the masterful computer scientist Charles Bennett. A simple example of computation is the addition of two numbers. Its inputs are the numbers x and y, 5 and 10 it could be, and the output is the number x plus y, 15. I think that could be a good time to I think this goes to show the utmost important breakthrough made from computer science about the very nature of the connection between matter and information. And as I think you understood by now, it also clearly shows the connection between res cogitans and res extensa. It seems that the Cartesian paradox is finally resolved, thanks first, of course, to quantum mechanics, with the brilliant pioneers of Bohr, Heisenberg, Schrödinger, de Broglie, and others, making something utterly new from their discovery that never ever in human history has been done. It took another whopping almost 90 years for the correct relation between observation and observed to be expounded and clarified. Many philosophers, great thinkers on the way, have been helpful, but also striving for the solution. Early on, Ludwig Wittgenstein, then of course Martin Heidegger, continuing his work, Merleau-Ponty, and truly getting into the essentials of oppositions and contradictions, Jacques Derrida, who showed that meaning is absolutely dependent on its contradictory nature. Meaning, understanding can never be one whole, consistent, coherent mass. It is constantly separating itself, going against itself, and thereby establishing existence by termination. Termination or ending itself is the only way of coming into being. To exist, to be, if you like. It's essential, foundational in the universe and in our thinking, knowledgeable character that the contradiction resides. Thank you very much. I'm a bit of a haze here of these marvelous discoveries made today. Thank you all for listening. Thank you, Alan Emrén, for your illustrious comments. And have a very pleasant afternoon, I say, here from the tropical house in the middle of Gothenburg. And now out into the rain. Look at the marvels. It's like recording in the jungle. Could be the Amazon basin.